Okay. This is the quadratic form. Y equals ax squared plus bx plus c. And y'all may remember something from last year where y'all had ax squared plus bx plus c equals 0. And you used the quadratic formula if you wouldn't factor, right? Yeah. This is all based around a parabola. That's what's happening here. All right. In this form, the a serves the same purpose as it did in the form the other day. Now, the x is squared, so this is either going to open up or down. Positive a goes up. Negative a goes down. Real familiar, huh? 1 over 4p still equals the absolute value of a. The drawing that you have from yesterday, I'm not putting back on the board, but guess what? That drawing still works. That's the reason I was pushing that drawing, because it works for all the forms. The drawing is good for all the forms. The vertex, and I'm going to teach you the shortcut. The vertex value is always negative b over 2a. The x value is always negative b over 2a. Forget rewriting them, forget completing the square, forget all the long ways of doing it. Right there tells you the x value. And then just use substitution to find the y value. So, take the x value, plug it back in, you get the y value. All right? Now, I'm going to add 2 little bits of information to this one. I'll add 2 bits. When you find the x-intercepts, you make y equals 0. To find x-intercepts, you make the y equal 0, and that's, remember what I just wrote on the board over there and I erased it, which I shouldn't have? That's what y'all were doing. When y'all were setting ax squared plus bx plus c equals 0, you may have not known it, but you were finding the x-intercepts right then. That's what they were teaching you to do. Man, I told you that, but that's what they were getting you ready for. Now, for y-intercepts, that's easy. For y-intercepts, you make x equals 0. All right? Because when x is equal to 0, you're on the y-axis, y-intercepts. When y equals 0, you're on the x-axis, you get y, x-intercepts. And we're going to add that just to this type. You could have done that for the ones I gave you the other day. Probably should have had to do that, but I didn't. But for these, we are going to do it. Okay. Everybody's got that written down. You know your picture is still good. Okay, here we go. We'll graph one. I had a pretty purple pen up here. I always try to avoid green because it reminds me of Captain Shreve, and we don't want any association with Shreve. The blue reminds me of Jesuit, but it's okay. All right. Y equals x squared plus 6x plus 5. Let's go ahead and pick one out here. Find the vertex. All right. I got to look to see if I got enough room to graph it over here to show up on the camera. Yeah, technology. You guys doing lots of technology stuff while we teach. All right. Find the vertex. It's negative 6 over 2 times 1. Because the a value is understood to be a 1. Okay, that's how you're going to find it. So the vertex is going to be negative 3 for the x value. The x value is negative 3. Now, trust that formula works. When you take calculus, you're going to talk about finding the highest point on the graph or the lowest point on the graph. and you'll get that formula minus b over 2a. And what that is, if you think about the vertex, it's either the lowest point on the graph, all right, or it is what? The highest. So the formula in calculus, they call it minimizing and maximizing. You're looking for the maximum value or the minimum, and that's, you get this formula, minus b over 2a. Now, once you get to negative 3, put it in here. Please, if you put it in a calculator, which I don't want you to do, you better put parentheses around that negative 3. Otherwise, your calculator spits out the wrong number. Right, hear that? You're squaring negative numbers in your calculator, you've got to put them in parentheses. So you get 9 minus 18 plus 5, negative 4. There is the vertex. Now, here's the problem with these graphs. I'm going to put the x-axis way up there. And I'm going to put the y-axis way over here. You want to zoom in when you do these, all right? Because you're going to get little bitty p-values. So just make your graph big, zoom in. Negative 3, negative 4. Negative 3, comma, negative 4. Can't put it that low on the board. I'll never be able to write that low all day. I'm going to raise it up a little bit. We'll see you a little bit. Negative 3, comma, negative 4. There's your vertex. A lot of times I just don't even worry about the x and y axis because they're really going to be way up there, right? Okay. Now, once I find that, I know it opens up. 1 over 4p equals 1. Mr. Evans, go back up and teach a little algebra. If you have to, put a 1 under there. Multiply both sides by the common denominator. 4p equals 1. P equals what? 1, 4. And there's where students just have a moment, because I know y'all, you're used to punching fractions in your calculator. Can't do that. Ready? Is everybody okay with the 1/4? If you're not okay with the 1/4, no hands up. Count up 1/4, and I'm going to go ahead and make that go up quite a bit. I'm not going to go up just that much, which is really what I should draw, but we'd never be able to see it. And that's going to be negative 3, comma, negative 3 and 3/4, right? Yeah. No, you're good. No, I want to hear that. That tells me somebody's out there listening. Only problem is don't write it as negative 3 and 3/4. Make it negative 15/4. There you go. No, that's perfect. I wish I could hear people telling me the right answers every once in a while before I write them down, instead of just not working. Or you're working, but it helps me. Now, yeah, get a common denominator, negative 4 plus 1/4. Get a common denominator, and you'll get that. All right? Now, when you count down 1/4, you're going to get negative 17/4. All right? And that's going to be y equals negative 17/4. The good news is, after you get one of them, you go up a fourth. It sure does make it a lot easier when you go what? Change that to a minus sign and go what? Down a fourth. All right? And doing good. Okay, now what do I have to do to the p-value? Multiply by 2. So I take the p-value and I multiply it by 2. Let's see if this will look different. 2 times 1/4. 1/2. So I'm going to count the left 1/2 and count the what? Right. So it's going to be negative 3 plus 1/2, which is negative 2.5 or what? Negative 5/2. So you go this way 1/2. Negative 5/2, comma, negative 15/4. And then you're going to go back this way 1/2, which will be negative 7/2, right? Negative 7/2. Now, when you go off to college, hopefully, most of y'all are going to skip algebra, college algebra. You're going to skip college pre-calc. But if you start a calc class, and they start throwing all those fractions up there, don't pull out your calculator, because you can't keep up. You got to be able to click them off. All right? Now, when it opens, we probably already realize my drawing is not as good as it needs to be. But I didn't go all the way up and go through my x-axis because I want to know what? Where my x-intercepts are and where my what? Y-intercepts are. Y-intercept is easy. Put 0 in for x. I'm going to do this in green because I think even the tree kids can do this. Y-intercept. 0 plus 0 plus 5. So the y-intercept is what? 5, comma, 0. 5, comma. Now, I'm just going to put way up there. 5, comma, 0 is a y-intercept up there. Is that okay? 5, comma, 0. Somebody says, Mr. Evans, you just made fun of the Shreve kids and you wrote it wrong. 0, comma, 5. Oh, the Shreve teacher's going to watch this and laugh. I don't know who the Shreve teacher is either. Okay, 0, 5, way up there. Now, let's do the x-intercepts. For the x-intercepts, I'm going to work it right up here just because I got room and they're going to be x-intercepts. You probably already know that one of them has got to be back here, right? Yeah, see, it can't be over here because your y-intercept would have been what? Down here. It's like a puzzle piece. Good? Okay. So, x squared plus 6x plus 5 equals 0. Factory. X plus 1, x plus 5, and you get negative 5, which would be, just make negative 5, comma 0, and the other one would be what? Negative 1, comma 0. And then once you get those, you can make a really pretty graph because you've got lots of information. You've got a lattice recti to help you get it started, and then you got the y-intercepts and x-intercepts to really make it pretty. I want you to notice something too. I'm just going to see if we can help you out here. Y'all got an axis of symmetry at x equals negative 3, right? Well, I'm just going to put it right here. I'm not going to do the whole thing because it makes it look bad. Axis of symmetry is x equals negative 3. Notice something about the axis of symmetry. Negative 3 plus 2 puts you where? Right there. Negative 3 minus 2 puts you what? Right there. Negative 3 plus 1/2 puts you there. Negative 3 minus 1/2 puts you there. So when you get that axis of symmetry concept going on, it's real easy to think, okay, I went so far this way, so far this way. And it also gives you a good check. Say I made a sign error here, and I said it was negative 3, 1 over there, negative 3, negative 5 back here. I know something's wrong because it's not what? Right in the middle. Okay? So it's one of those little safeguards. And folks, that is how you deal with the quadratic form. What if it doesn't factor? You must use what to find the x-intercepts? Quadratic formula. Now, if you do not know the quadratic formula, I can understand that. You'll know it soon, right? Quadratic formula. For the form ax squared plus bx plus c equals 0. X equals negative b plus or minus square root b squared minus 4ac over 2a, right? Right, over 2a. Do you know, I'm going to do something here that I'm going to write this, and then you probably don't want to write it. I'm going to write it as two separate fractions with a big plus minus. This is not how it looks, and I'm going to rewrite it in just a second. What am I trying to get across to you there by writing as two separate fractions? See the negative b over 2a? That's your what? That's your x value of the vertex, right? Is that cool? And what's the x value of vertex turn out to be? Axis of symmetry. And so what happened when you were using the quadratic formula, it was finding the axis of symmetry for you and then telling you to add in one direction this amount and then do what? Subtract it to go, yeah. See, the quadratic formula right there is your axis of symmetry. And then it's telling you to either add to it or do what? Subtract. Okay, so there's that negative b over 2a. And now, when we really write it, we don't write it as two separate fractions, though, do we? If you did, it wouldn't hurt if you wrote it like this, because it would sure come out real pretty when you're graphing them. Because you would always get whatever your vertex was, x value vertex, plus, and then what? Minus. So if you want to write them like that, it's not wrong, and it's easier to simplify. Okay? It's a lot easier to simplify if you write them like this. Because then you can reduce this fraction, and then you just get your part over here that's done. Okay? So if you want to do that, that's fine. But that'll give you your axis of symmetry. Now, you were probably looking at it going, Mr. Evans, work one that has the quadratic formula in it. Okay. Let's make up one that has the quadratic formula in it. Let's do that. I want the first one, the graph, real pretty. But I like the quadratic formula written like that. I don't know if I should really do one of these. I probably should just put it in your classwork and you have to do it. Okay, here we go. Y equals 4x squared plus 8x minus 1. There we go. Notice I didn't make my vertex easy to find, didn't I? If I'm getting to make it up and I'm going to have to use a quadratic formula, I wanted my vertex to be easy to find. Okay, let's find the vertex. Negative 8 over 2 times 4, and we get a value of what? 1. Negative 1. And notice how I always do that in a little line like that where I can work it out, and I ended up with it. One thing we're trying to accomplish here is to make it where you can follow patterns. All right? Make it where you can follow patterns. All right. You put the negative 1 in there, and you get 4 minus 8 minus 1 is negative 5. Negative 1, negative 5. Put that point down here. Negative 1, comma, negative 5. Put a little b by it, getting out. P-values, all that good stuff. Okay, let's get the p-value. The p-value is a little bitty. It's 1/16. All right, because you get 16p equals 1. P is going to equal what? 1/16. Now you see what's the problem with these. The p-values are always nasty little fractions down there. All right, I'm going to make 1/16 a lot more than it really is supposed to be. Negative 1, and it's going to be negative 5 plus 1/16, 89/16. Because it'd be negative 5 5 times 16 is 80. So try 79 sixteenths, Mr. Evans. 79 sixteenths. Yeah. All right? Keep looking at that thinking, wow. Negative 79 sixteenths. Someone says, I would double check that if I were you. 5 times 6 is 80, right? Okay? And then negative 80 plus 1. And then I got to do the one that's below it, which is going to be negative 81 sixteenths. I'm not enjoying this because I really just want to show you how to find the what? X-intercepts, right? But I'm going ahead and reviewing the whole story. So far, what is the next step? What do I do to my p-value? Multiply it by 2. So I multiply 2 times 1/16. Get 1/8. So I'm going to get negative 1 plus an 8, which is not too hard. That's negative 7/8. And you don't have to work out the y value again, folks. It's not going to change because you're only moving what? Left and right. And then we get negative 9/8, comma, negative 79 over 16. The y-intercept is probably really easy to find. What's the y-intercept in this case? Negative 1. 0, comma, negative 1. Okay, there's your y-intercept. X-intercepts. I'm going to erase a little bit so I have room to work. So I want to give you a moment to look at it real close. I want you to think about what you're looking at and see what we got. See how we're doing. I want to lean for a moment. I hate to erase that, but everybody's okay with that part. And y'all realize you can put them one as. When you were being taught whole numbers back in the first grade, if we had just put them all over 1, it'd have been awesome because you'd learn how to do fractions. All whole numbers already have a common denominator, 1. Okay, here we go. I'm going to use my little formula like that. I just got to because it's so cool. Okay, x equals negative b, so negative 8 over 2 times 4 plus or minus square root b squared minus 4 times a times c, and then that's going to be over what? 8, 2 times 4. I just got to do it that way because I just like the idea that this is going to give me my what? Axis of symmetry. So I'm going to get x equals negative 1 plus or minus square root of 80. Yeah, square root of 80. Now, before we do anything here, I'm just going to write that down, but everyone here already knows that that needs to be reduced, right? Okay? Yeah, because that's 16 times 5. And what is the square root of 16? 4. It's going to work out nice. So negative 1 plus or minus 4 square roots of 5 over 8. And then what can we do? 4 over 8 gives you the 2. What will happen, if you'll write it as 2 separate fractions like this, it'll always reduce prettier. It'll always reduce a lot prettier. 16 times 5, square root of 16 is 4. Bring down. So what happens is, this one over here has to be the negative 1 plus square root of 5 over 2. And this one over here has to be the one that's what? Negative 1 minus square root of 5 over 2. and that axis of symmetry is just sitting there waiting on us. See, if you'll do it this way, this number right here will always work out to be your axis of symmetry. So it gives you a little safeguard, a little check. I'm supposed to ask questions to see if you're understanding this, but if you didn't understand it, you'd wave at me, right? Okay. Now, I want everybody looking at me for a second. I want you happy with what you got, because I'm going to ask you the question. Y'all use the quadratic formula, and y'all got eyes. Did y'all get eyes every once in a while? Imaginary numbers. Yeah, you got complex numbers where it had real numbers and it had the little eye. Okay, here's your x-axis. Here's your parabola. Does it ever really cross the x-axis? If you use the quadratic formula to try to find x-intercepts and it doesn't cross the x-axis, that's when you get the eyes. This is the case where you would get eyes. You would show eyes for your x-intercepts because it really doesn't what? Cross the x-axis. So when you graph it, if it doesn't cross the x-axis, don't go looking for x-intercepts because you're going to get what? Eyes. You're going to get those imaginary complex numbers, and we're not using those yet. We're not going to fool with those yet. But always have to do this. That's the reason when y'all were doing this before, you got the eyes. Because if you were to graph that parabola, it never really crossed the x-axis. Okay? So that now we're going back and showing you something that relates to what you've already done. All right, now we'll turn this off so that